Acid rain is classified as any rain that has a pH value less than 5.6, and its presence can have many damaging impacts on the environment, including reducing diversity in aquatic environments, tree death, and corrosion. Acid rain forms as a limitation of fossil fuel power plants, as they release large amounts of sulfur dioxide into the environment, which led to public debate regarding the negative impact of large-scale power plant construction in England. As such, solutions were developed and applied that utilized the scientific knowledge of the chemical properties of sulfur dioxide, eventually resulting in the beneficial consequence of greatly reducing sulfur dioxide emissions. Acid rain is formed by the presence of sulfur oxides and nitrous oxides within the atmosphere, such as the sulfur dioxide formed from the oxidation of sulfur within coal during the combustion of fossil fuels in power plants. This then oxidizes and hydrates to form sulfuric acid, which ionizes completely in falling rain due to sulfuric acid being a strong acid to make rain more acidic, forming acid rain. To prevent this sulfur dioxide is removed from flue gases, the emission gases from power plants, through wet scrubbing. First, the flue gas is moved by a booster fan into an absorber tower, where it rises into a limestone slurry spray, a mixture of water and pulverized calcium carbonate in the form of limestone. Here, the desulfurization begins. As sulfur dioxide is unstable, it reacts with water in the slurry to form hydrogen sulfide, otherwise known as sulfurous acid, in a hydration reaction. Sulfurous acid is acidic, thus it releases hydrogen ions or protons into the aqueous solution it is a part of, and since it releases two protons, it can also be classified as diprotic. Thus, sulfurous acid forms two hydrogen ions and a sulfide ion as it dissociates. At this point, the pH of the solution is lowered, as hydrogen ions are released, making the solution increasingly acidic, which is neutralized by the alkaline calcium carbonate. As it is basic, it accepts the protons donated from hydrogen sulfide. Finally, the remaining ionic substances react to form solid calcium sulfide, neutralizing the solution. Overall, wet scrubbing allows sulfur dioxide to be removed from flue gases through the formation of solid calcium sulfide, preventing the formation of acid rain through a neutralization reaction. Due to the knowledge that sulfur dioxide is both a byproduct of fossil fuels and a key factor in acid rain formation, concerns within the 1920s public arose regarding the construction of large-scale power plants in England. As it was known that acid rain resulted from the burning of fossil fuels emitting sulfur dioxide, the English public began to become concerned with the construction of large-scale power plants in 1920s England. This specifically worried one landowner who, in 1929, claimed that the sulfur dioxide emissions of Barton Electricity Works had damaged his property, a claim upheld by the House of Lords, resulting in the imposition of sulfur dioxide emissions controls on power plants, and thus research into flue gas desulfurization technologies. Hence, public debate was informed by the science around the formation of acid rain from power plant emissions, with growing concerns influencing science by incentivizing research into flue gas desulfurization technologies. Throughout the 1900s, this research and development continued, with scientists attempting to develop a solution utilizing their knowledge about the reactions of sulfur dioxide. This eventually culminated in experimentation with scrubbing technologies with aqueous solutions that contained various alkaline compounds such as calcium carbonate. Although the workings were not fully understood, scientists used their scientific knowledge to deduce that sulfur dioxide was hydrated, forming sulfurous acid, and dissociated within the solution, releasing two protons, which reacted with dissolved calcium carbonate, resulting in the removal of sulfur dioxide from the flue gas, a process dubbed wet scrubbing. Essentially, scientists utilized their knowledge of neutralization reactions to develop a solution to sulfur dioxide emission in power plants. However, upon first application of wet scrubbing, there were numerous unexpected problems within the design, providing opportunities for improvement, resulting in the limitation of sulfur dioxide emissions seen today. Upon first installment into a large-scale power plant, several unexpected problems arose specifically regarding corrosion from the presence of corrosive acids. These provided opportunity for innovation, as several test facilities began researching solutions, eventually resulting in modern wet scrubbing implementations. These have had the beneficial consequence of being capable of removing up to 98% of sulfur dioxide from flue gas. Thus, through innovation in the design of early wet scrubbing technology, unexpected design flaws were solved, allowing the application of flue gas desulfurization to have beneficial consequences, such as limiting the formation of acid rain. However, despite these high removal efficiencies, combustion of fossil fuels still leaves much to be desired in way of preventing the effect of producing electricity on the environment. One example of this is the emission of carbon dioxide, produced by the oxidation of carbon within coal during combustion, which is a harmful greenhouse gas, contributing to the greenhouse effect and consequentially global warming. Thus, in the interest of creating an environmentally safer future, the use of renewable energy sources is highly recommended, By utilizing solar, wind, and nuclear power generation, combustion is completely eliminated, thus disallowing the formation of carbon dioxide, sulfur oxides, and nitrous oxides, preventing the formation of acid rain and warming of the earth due to greenhouse gases. Acid rain is a natural phenomenon exacerbated by human combustion of fossil fuels releasing sulfur dioxide into the atmosphere, where it oxidizes and hydrates to form sulfuric acid, raising the acidity of rain it encounters. Due to this scientific knowledge, the public began to become concerned with the construction of power plants in England during the 1920s, influencing science as the development of flue gas desulfurization research began because of restrictions placed on sulfur dioxide emissions. This led to the development of wet scrubbing, where the scientific knowledge of sulfur dioxide's properties and neutralization reactions allowed sulfur dioxide to become calcium sulfide, allowing scientists to develop an applicable solution to prevent acid rain formation. Finally, this resulted in the beneficial consequence of sulfur removal efficiencies of up to 98%, allowing the limitation of fossil fuel power plants to be mitigated through the application of wet scrubbing.
Created using Powtoon.